In this section, we're going to continue talking about logarithms. We're going to go ahead and look into logarithm functions and then how to solve logarithm equations. So we're going to go ahead and start this video by talking about the domain of logarithms. In a previous video, I mentioned that the domain goes from 0 to infinity, but I told you that the domain may change depending on any transformation the graph encounters. So we're going to go ahead and figure out how to find the domain of a logarithm. So this is pretty much what we're going to be doing. Whenever you encounter a problem and where they're asking you to find the domain, you just have to set whatever is being evaluated in the logarithm greater to 0 and solve. That's it. So again, if this doesn't make sense, don't worry, we're going to be doing two problems together. So here we go. This is one of the problems, right? They're asking you to find the domain of this problem in interval notation. Now, whenever the note said, right, the note said set whatever is being evaluated greater than 0. What I mean by that is anything in parentheses, that's all we're going to care about. So I don't care about the base of the log. I don't care if it's a log or an ln. I really don't care about that. All I care about is whatever is inside the parentheses. So all I'm going to do, whatever the notes say, is I'm going to set the 8 plus x greater than 0. This is always going to be the case. You always set it greater than or equal, or sorry, greater than or than 0. Always. If you want to know why, the reason is logarithms cannot evaluate negative numbers and it cannot evaluate 0 values. So it only evaluates numbers that are positive. So for this reason, we have to check when 8 plus x is going to be greater than 0 or a positive answer. So from here, all you have to do is just solve it. So the only thing I have to do is to leave the x by itself is subtract 8 from both sides. So I'm left with x is greater than negative 8. Now, just remember this. If you're solving something like this and for some reason you end up dividing or multiplying by a negative number, remember the sign flips. In this case, we didn't have to flip anything because all I did was subtract an 8 from both sides. So I subtract 8, and believe it or not, that's my final answer. X is greater than negative 8, but again, since you're asking it for interval notation, I do have to rewrite it. X is greater than negative 8, so negative 8 is right here, and greater than, oh my goodness, I'm so sorry about my weird 8, but you get it. Negative 8, and then greater than means anything to that side. So my answer is from negative 8 to positive infinity. Okay, that's how easy you find the domain. Again, as a reminder, you're always going to use the symbol greater than, and since it doesn't have an equal to, you're always going to use parentheses here. Okay, so infinities always go with parentheses, and negative 8 is going to go with the parentheses because this one is just a greater than symbol. All right, I am going to warn you, things get a little more interesting when you have a problem like this. Again, I don't care about the log or the ln. I don't care about the base. If you have a different number here, like a 7 or a 4, it doesn't matter. The procedure would be the same thing. All I care about is this right here. So again, same thing. I'm going to grab whatever is being evaluated, which in this case is x squared minus 9, and I'm going to set it greater than 0. Now, to solve this is where it starts getting a little tricky. When you have a problem like this one where it's greater than 0, you are going to have to factor this out, okay? This should not be new to you. We did cover this in a video of polynomial inequalities. You have to factor this out. Now, this is a polynomial that it's super easy to factor out because the square root of x squared is just x and x, and the square root of 9 is just 3 and 3. Okay, it's always going to be the case when you have a difference of squares. Now, when you factor this out, it's always one positive and one negative. Okay, so if this would have been x squared minus 25, it would have been x minus 5, x plus 5. Okay, it's always going to be like that. Now, I know you hate this, but the only way we could solve a inequality like this one is doing a number line because we have two boundary points. Again, let me just go back to the previous problem. In this one, we only had to move something to that side, and voila, we were done. X was greater than negative 8. Now in this problem, we have two x's and x squared. So we're going to end up with two boundary points. So that's the only way we're going to be able to solve this problem. So here's my work. I'm not going to go very deep into it because again, there's a whole video about polynomial inequalities, but this is pretty much what you do. If I solve this, I set it equal to 0, I get the positive 3. And if I set this equal to 0, remember it just flips the sign, so I get the -3. So I have 3 intervals created. I have from -infinity to -3, from -3 to 3, and from 3 to +infinity. Now, we're going to have to test points. So what I do is I choose a number. From here, I chose -4. On this interval, I chose 0. And on this interval, I chose 4. To evaluate them, I'm just going to come back to this one. Please don't go back to the log because, again, to find the domain, we just care about whatever's inside. So what I do is I'm going to put the number that I chose, which here in this case was -4. I put it into here. So -4 squared minus 9, I got a +7. And again, we're looking for numbers that are greater than 0. So this one is greater than 0. So there we go. Now, in my second interval, I chose 0. So 0 squared minus 9 gives me a -9. -9 is not greater than 0. So this is not one of my answers. And then for my third interval, I chose the number 4. 4 squared is 16 minus 9 gives me a +7. Again, I don't care about the number. It's positive, so it is greater than 0. So there we go. And that's it. My domain are obviously the 2 intervals that worked. So my domain and interval notation for this problem was from -infinity to -3, union from 3 to infinity. I'm sorry about this. Go ahead and erase that. So it's this interval here, -infinity to -3, and then 3 to +infinity. So I just want you to be ready for that. Again, as soon as you see an x squared, you're going to have to do a number line because you have 2 boundary points and you're going to have to test intervals. And just remember, it's always going to be the numbers that are greater than 0. All right, that was enough for domains. Now we're going to go into the good stuff in this video, which is solving logarithm equations. I know the previous video we solved some equations, but right now we're going to go more in depth into a little more complex logarithm equations. So here are the steps we're going to be using for solving logarithm equations. Step 1, we have to have a single logarithm on one side of the equation. Regardless, if we have 2 logarithms, we're going to have to combine them. We always have to have just one single logarithm on one side of the equation. Once we have a single log, we're going to have to rewrite the log as an exponential equation. Okay, so if you forgot that, make sure you go back to your notes. We talked about how to convert a log into an exponential. Once it's an exponential, now we could solve it because there's going to be no more logarithms that are going to be bothering us. And now the last thing that we're going to do, once you solve the problem and you find your answer, you are going to have to analyze your answers because some of them are not going to be able to be used. So we're going to disregard any answer that is out of the domain. Okay, and don't worry, we're going to be talking about that when we do our problem. Okay, and again, just as a reminder, because these are very important properties, are going to help us out. If you remember step 1, we have to have a single logarithm. So we have 2 logarithms that have the same base. We're going to have to convert them into a single log. So just as a reminder, when you have 2 logs that are being added, you could convert them into one log, but you're going to multiply whatever they had in each of the logs. And again, another reminder, when they are being subtracted, you're going to rewrite it as a division problem. And then, like I mentioned earlier, when you have a log, you have to convert it to an exponential. So this is just a reminder how to convert between the 2 different formats. So if you have a log, you have the base to that exponent equals this right here, right? So it becomes b to the y equals x, and the log is gone. So this is a very important little feature or little rule that's going to be helping us solve our equations. All right, so let's go ahead and get to the good stuff. Here we go, we have a problem and we go through the steps, right? So step 1 is make sure you have a single logarithm on one side of the equation. Lucky for us, that's it. There's only one log, there's nothing on this side, so step 1 is done. Step 2, we're going to have to rewrite this as an exponential. So to get rid of the log, we're going to rewrite it, and hopefully you remember it's 6 as a base to the exponent of 9 equals v. So there we go. 6 to the 9 equals v. The logarithm is gone. And that's it, right? V is going to be whatever 6 to the 9 is. You could evaluate this in your calculator and we're done. V equals all of that huge number, right? I'm not even going to dare try to say it, but that's what you would get. Now, if you remember step 4, it says disregard any answer that is out of the domain. As we remember, the log The domain of this is numbers that are greater than 0. Obviously, if this number is greater than 0, that's why that's our final answer. If for some reason this answer would have ended up being negative, I would have had to disregard it because again, the domain states that they have to be values that are greater than 0. Okay, so for this one, no problem. Now let's go ahead and try this one again. Step 1, make sure you have a single logarithm. We only have one, so step 1 is done. Step 2, we're going to have to rewrite this. Again, this is a procedure. 2 is my base to the power of 4 equals everything inside the parentheses. So there we go. 2 to the 4 equals 3x plus 4. Again, the log is gone, so our life is so much easier. From here, all we have to do is solve, right? We have to leave the x by itself. So let's go ahead and start by calculating whatever 2 to the 4 is. So 2 to the 4 is 2 times 2 times 2 times 2, which gives me 16, equals 3x plus 4. Again, we know that in order to solve this, we have to leave the x by itself. So I'm going to move the 4 to this side, making it negative. So 16 minus 4 gives me 12, equals 3x. And hopefully from here you agree with me. The last thing we have to do is just divide both sides by 3. If I divide both sides by 3, I get x equals 4. Super simple. Again, just to make sure our answer works, let's go ahead and plug in the 4 here. 3 times 4 gives me 12, plus 4 gives me 16. That is going to give me a number that is greater than 0. So, no problem whatsoever. I accept this as my answer. Again, if you would have gotten an answer that is suspicious, you would just substitute it here. And if you end up getting a negative number, that means that answer cannot be used because, again, logarithms only evaluate numbers that are greater than 0. But again, in this problem, we don't have any issues, so that's my final answer. All right. Here we have another example. Solve and leave the answer in exact form. Always read the instructions because remember the instructions tell you if they want you to round or leave it as is. Now, if you look at this problem, we run into some issues because again, step 1 is to have a single logarithm, but in this one we have 2. Lucky for us, we know how to rewrite this. So we have 2 logs that have the same base. Of course, they don't have a base, but we know it's an invisible base of 10. Now, these 2 logs are being subtracted. So in order to have a single log, I'm going to combine both of these. Since this is a subtraction, I'm going to combine it into a division. Now, when you have 2 logarithms, they become 1. Whatever you had in the first goes in the numerator. Because it's a subtraction, it becomes a division. And whatever you had on the second becomes your denominator. You don't worry at all about the right side. So, again, step 1 is done. I have a single logarithm now because I rewrote both of these into 1. Now, step 2 is to convert this into an exponential. To convert this into an exponential, we start with a base. Since there's no base, remember it's an invisible 10. And then I just rewrite it. So I'm going to have 10 to the power of 1 equals this whole mess. So I have 10 to the power of 1 equals that. Once you rewrite it as an exponential, the logarithm is gone. Again, this looks very scary, but trust me, it's going to be super simple. All I have to do now is 10 to the first power is just 10. And then I'm going to multiply both sides by the denominator. So I'm going to multiply this side by x plus 2. And what I do to one side, I have to do it to the other. So I'm going to come over here and also multiply this times x plus 2. Now, the reason I did that is because, again, these cancel out. So I'm just left with x plus 3. And on this side, again, please do not forget you have to put parentheses. Now, the fraction is gone. Now, to solve this, I am going to have to distribute the 10, leaving me with 10x plus 20 equals x plus 3. No more logarithms, no more exponents, no more fractions. We know how to solve this now. We have to have the x's on one side, so I'm going to move this x to this side, giving me a negative x. So 10x minus x gives me 9x. And then I'm going to throw this positive 20 to this side, making it negative. So 3 minus 20 gives me the negative 17. From here, we just have to divide both sides by 9. And I get my final answer of x equals negative 17 over 9. And there we go. That's my answer since they wanted it in exact form. Now, I know what you're thinking. Ms. Moreno just said that we cannot have negative answers. Here's the deal though. If I put a negative 17 over 9 in this x, when I add the 2, it becomes a positive number. So it works here. Same thing here. If I plug in the negative 17 over 9 here and I add the 3, it also becomes a positive answer. Okay, that's why this answer does not give us any issues. Again, because when I substitute them into here, it turns positive, which is okay. All right, so that's my final answer for this problem. All right, let's go ahead and try another one here before we move on to something else. Solve and round. Okay, so now in this one, we're not going to leave it as a fraction. We're going to have to round up. Now, same thing as the last one. We have to convert these two logs into a single log. Now we're going to ask ourselves, what are we going to do? Since there's an addition, I'm going to combine both logs using multiplication because that's what the property says. So these two logs combine into just a single log, and whatever was in the parentheses is going to be multiplied. Again, since there's two things, we're going to have to FOIL, right? So, or not FOIL, but distribute. So x times x, that's how I got the x squared. And then the x times 3, that's how I got the 3x. The right side stays exactly the same. So again, if you have no idea what I'm doing, I'm just using the properties. Remember, the property says that when we add, we combine them into a single log, and whatever was inside the parentheses is multiplied. So step 1 is done. I have a single log now. Step 2, I'm going to have to rewrite this as an exponential. Again, same thing. We're going to have 6 to the power of 1 equals this whole thing. So 6 to the power of 1. Again, the log disappears because I converted it into an exponential. From here, we know what to do. 6 to the power of 1 is just 6. And then x squared plus 3x stays there. Now, in order to solve this, I have to move the 6 to the other side. So 6 to the 1 is just 6. But if I move it to this side, it becomes a negative 6. Okay, hopefully you're okay up to this point with me because it's going to get crazy from here on out. Take a deep breath and be ready. Now, this is a quadratic equation. In order to solve this, we can either factor or just go straight to the quadratic formula. I'm going to save you the time. This problem is not factorable. There's not two numbers that multiply to negative 6 and add to 3. So we're going to have to use the quadratic formula. Okay, so if you thought that was over, I'm so sorry, it's back, but it's super easy to solve. Again, the reason you know we have to use the quadratic formula, again, is because we have an x squared right here. And then we have two other things. So we have our a, our b, and our c. So just as a reminder, quadratic formula requires an a value, which in this case is going to be a 1. It requires a b value, which in this case is positive 3. And it requires a c value, which in this case is negative 6. So here's my quadratic formula with my values substituted in there. Again, I'm not going to go very much in depth into it. You just replace the letters, right? So we have negative b plus or minus b squared minus 4ac all over 2a. And you simplify. So negative 3 gives me negative 3. 2 times 1 gives me 2. I put this whole thing in my calculator and I got 33. Now, good news for you is that you don't have to worry about simplifying or making sure the radical is super simplified because they want the answer as a decimal. So all you have to do is just put this in your calculator. Okay? Before I do anything though, I am going to warn you. You have two answers. So you're going to have to calculate this in your calculator twice. You're going to do one where you have negative 3 plus the square root of 33 over 2. Again, but with a negative 3 minus the square root of 33 over 2. Okay, so once I did that in my calculator, I got these two answers. And again, of course, I rounded so they're not the exact answer because they just keep on going forever. This was my first answer here, 1.37. This is the answer that I got when I did the plus. And then when I did the minus, I got the negative 4 over 37. Okay, so yes, we do have two answers, but again, step 4 says that we have to disregard the one that's not going to work. Sometimes they both don't work. Sometimes they both do work. Sometimes one of them does and one of them doesn't. So this is what we're going to do. If I replace the positive 1 over 37 here and here, it works, because again, the domain says that they have to be positive answers. Now, if I replace a negative 4.37 here, it's going to stay as a negative 4.37. And we just learned that logs do not evaluate negative answers. It only evaluates numbers that are positive. So for this reason, I'm going to have to disregard this answer. So my only answer for this problem is going to be the 1.37. Okay, so make sure you make a note of that, because I don't want you to do the whole problem and then enter both of the answers and get the problem wrong. You always have to disregard the one that doesn't work. In this problem, this one did work, again, because it's a positive value, and this one doesn't. If you're not sure, just pull out your calculator. Go ahead and put log of negative 4.37, and you're going to get an error message. So again, that's how you know that this one doesn't work. And then this one is going to end up being my only answer. Again, I didn't show you the whole decimal, but if you do need help rounding, let me know. But this one was the rounded answer already to 2 decimal places. All right, that was pretty fun. Let's go ahead and do a couple more problems, but for the rest of the problems we're going to be doing today, I do want to remind you of this, right? When you have an equation that consists of only one logarithm of each side of the equation, but they have the same base, we are going to be able to drop them. So this is something new, but it's going to come in handy very nicely for the next couple of problems. Make sure you remember this. When you have one logarithm, and by this, I mean only logarithms. Let me go ahead and go back to the previous problem. If you notice here, we had logarithms, but we also had this little number just bothering, right? It was just there. So that's why we had to solve it the way we did here. But for the next couple of problems, I want you to remember this. If you only have logarithms, no numbers extra, just logarithms, and you're able to manage to have one on each side of the equation, you're going to be able to drop them, and it's going to make our lives so much easier. So this is what I mean. In this problem, if you notice, there's no extra numbers. We just have a log, and a log. There's no like +8 or +11 on this side. They're just logs. So what we're going to try to do now is make sure we have just one log on the left side and one log on the right side. And from there, trust me, our lives are going to be so much easier. So what I'm going to do here, in the left side, I already have a single log, but on the right side, I have 2. But again, we are experts on this. We know how to combine both of these 2 into a single log. Since this is an addition, all I have to do is multiply these 2 and rewrite them as a single log. So on the left side, that just comes down the way it is. And on these 2, I'm going to combine them to one log. But again, since this was addition, I'm going to multiply the x and the 7, giving me 7x. Okay? Now, this is what I'm talking about. This is so pretty. Because since you only have one log here and one log there, and they're the same base, because again, this one has an invisible 10, that one has an invisible 10, you can drop them. And look at that. Our problem just became so much easier. It's just x plus 7 equals 7x. Again, you can only do this when you only have logs. There's no extra numbers that are bothering us. We just leave it like that. And again, you guys know how to do this. We just solve this by moving things around. So I'm going to go ahead and move this 7x to this side. It becomes negative. So x minus 7x, that's how I got the negative 6x. And this one doesn't have an x, so I throw it to the other side and becomes a negative 7. All right. Believe it or not, we are kind of done, because the only thing I have to do now is divide both sides by negative 6. And I get my final answer of 7/6. Again, it becomes positive because the negative 7 over the negative 6, negative divided by negative is a positive. And this right here is my final answer. Just like before though, I am going to have to check if it works. So 7/6 is positive. So if I put it here, it's obviously going to work because it's a positive answer. If I put it here, plus the 7 is going to make it even more positive. So this one is going to work without any issues. So that's my final answer. Okay, so I'm hoping you like the problem, because again, trying to show you here that when you have just logs, it makes the problem so much easier. Because once you get to this step where you only have a single log on each side, you could just drop them and it gets rid of everything. Let's go ahead and try just 2 more problems here. Okay, I forgot here. Since the equation did ask us to round off or give the answer decimal, you just have to put in your calculator 7/6 and just make sure you round properly to get the answer they were asking you for. All right, let's go ahead and try this one here. This one is so much prettier because this one already has one log on the right side and one log on the left side. And again, make sure you double check that the bases are the same. Since the bases are the same, look at that. It's so easy. I just get rid of them. And I'm just left with 17x plus 97 equals 21. Okay, that's all we had to do. Now from here, we just solved by moving things around. I want to leave the x by itself. So I'm going to move the 97 to this side. It's going to make it negative. So 21 minus 97 gives me negative 76. From here, to leave the x by itself, I divide both sides by 17. And look at that. They were asking for exact form. Remember, exact form means you just leave it the way it is. And that's it. Look at that. My final answer is that. Again, it's a negative answer. So you always want to check, go back to the problem and see if it works. So the way I would do this is I would substitute this into that x in the original problem. Go ahead and do 17 times negative 76 over 17. You're going to get negative 76. But when you add the 97, it becomes a positive number, meaning that it's going to give us no problems. So that's why that is my final answer. Just as a reminder, if I go back and I plug in that number in the x, and after I evaluate all of this, I get a negative answer, then I would have to delete this answer. It wouldn't work because it gives me a negative at the end of the day. But again, since it works out very nicely, I plug it in and I end up with a positive number. It's okay, it works. All right, the last problem for this video is this one right here. Again, just like any other problem, you notice that there's only logs, right? In this case, they're ln's. So that means that I could use the same base property where I could just drop them. But in order to do that, I have to have a single ln on this side. Okay, so I'm going to have to squish those together. Again, we already know since this is an addition problem, I'm going to go ahead and squish them together by multiplication. So I'm going to put ln, just one ln now, and I'm going to multiply this. So x times x is x squared, and then x times negative 7 is negative 7x. On this side, I just have 6x, so that just comes down like that. Now that I have the same log on both sides, in this case ln, I could magically just drop them, forget that they exist, and I'm just left with x squared minus 7x equals 6x. Now, this is where you can start cringing because remember, if you remember from a problem earlier, when you have an x squared, the quadratic formula is going to have to come help us, right? But in order to have the quadratic formula ready to use, we have to have everything on the same side. So I'm going to go ahead and move this to that side, giving me x squared minus 7x minus 6x gives me negative 13x equals 0. Now, if you want to use the quadratic formula, you can. This would be your a value, this would be your b value, and then your c value, since there's nothing, would be a 0. So feel free and go ahead, but I am going to show you an easier way. This one, I know I said you have to use a quadratic formula, but we can get around with using it because, again, there's no c value to worry about. So what I'm going to do here is, if you notice, I'm going to factor this out because if you notice, again, both of these have an x in common. So I'm going to go ahead and factor out an x. I'm going to have an x outside, and x stays here, and then if I factor out an x, I'm left with a minus 13. Now, to find my answers, all I have to do is just set this equal to 0, giving me a 0. And if I set this equal to 0, I get a positive 13. Okay, so I have my final two answers. Those are my two answers. Let me just go ahead and do something real quick here. Let me just go ahead and remind you what we did. We had to rewrite the addition problem into multiplication. So I had to multiply that times that. Once the ln's were the same, I dropped them, leaving me with just this problem. I threw the 6x to this side. It becomes negative. So negative 7x minus the 6x give me the negative 13x. Like I said, you could, up to this point, here, after that, you could use the quadratic formula. If you just love the quadratic formula, feel free. What I did was just show you how to do it by factoring. So I went ahead and factored this into the greatest common factor, which was x minus 13. And from here, you just set each one of those equal to 0. So x equals 0 gives me my first answer. And then x minus 13, I set it equal to 0. It flips the sign, so I get my second answer. Now, before you stop the video and be like, I'm done, no, we're not. Remember, step 4 is always check your answers. So if I plug the 0 back in here, I'm going to have ln of 0. But earlier we learned that logs only evaluate numbers that are positive. So for that reason, I'm going to have to disregard this answer. Okay, because again, put it in your calculator. Go ahead and put ln of 0 and you're going to get an error message. It doesn't work. Same thing goes. If I put the 0 here, I'm going to have 0 minus 7, which is a negative 7. I cannot have negatives inside of a log or an ln. So again, even though you think we were done, like we have our final two answers, we had to come back and disregard this one. Now, just for fun, I am going to try the 13, see if it works. If I put the 13 here, it's going to be a positive 13, so that's okay, that works. If I put the 13 here, 13 minus 7 gives me 6, positive 6, so that's still okay. And if I put the 13 here, 6 times 13, I have no idea what it is, but it's going to end up being a positive answer, which is okay. So my final answer for this problem is just 13. Even though I did get two answers, remember you always have to double check and see which ones work. Sometimes they both will work, sometimes both of them won't work, and you're actually going to have no final answer. And then sometimes, like in this case, one works and one doesn't. So just make sure you don't forget, always double check your answers.